System planning. In this video, we are going to see about system planning. Data and fact gathering techniques. The specific methods that an analyst is used for collecting data about the requirement of a new system are called fact-finding techniques. Interview. In this technique, analyst collects information from individuals. It is a formal meeting where the analyst can obtain information about the operation of the present system and requirements of the planned system. Types of interview. Structured interview. In a structured interview, interviewer has a specific set of questions to ask. All questions prepared in advance and answers are already available. Unstructured interview. In this method, questions and corresponding responses are open-ended. This is conducted with a general goal or subject. Planning for interview. Purpose of interview should be clear. The purpose of meeting is clearly explained to all participants so that relevant document can be supplied in advance. Proper time, duration, and place for interview must be selected before, so this will allow the participant to schedule work accordingly. Questionnaires. Questionnaires are special purpose documents that allow the analyst to collect information and opinions from respondents. This is more structured and formal method of collecting data. Types of questionnaires. Structured, answer and questions are fixed. Unstructured, not fixed pattern. On-site observation. On-site observation allows the analyst to gain information which cannot be obtained by other fact-finding methods. It is also useful when analysts need to actually observe how documents are handled, what processes are carried on, etc. On-site observation provides close view of working of the real system. The analyst can observe people, objects, documents, and occurrence of events. Installation. The process of moving from the current information system to the new one is called an installation. All employees who use a system, regardless of whether they were consulted during the development process or not, must give up their reliance on the current system and begin to rely on the new system. 4 different approaches to installation have emerged over the years: direct, parallel, single location, phased. The representation of the system planning. Introduction to conversion methods. In this video, we are going to see about the introduction to conversion methods. Conversion means changing from one system to another, that is, changing from the old system to the new system. When the new system is fully tested and proved, conversion from old to new is possible. Activities involved in conversion plan are given as follows. Converting the files and database from the old system to the new system. User training to all members of the organization in which the new system is deployed. Converting forms. This may involve discarding of old forms, manual registers, etc. Converting physical activities, for example, replacing old input or output devices with a new one. Converting administrative procedure, that is, defining role of different members, assigning responsibilities to them as per the requirements of the new system. Checking the result of the new system with the data, etc. Conversion methods. In this video, we are going to see about the conversion methods. There are 4 methods of conversion. Each method has its own advantage and disadvantage. No single method is suitable for converting all types of system. The following are the 4 conversion methods: parallel system, direct cutover, pilot approach, phase-in method. Parallel system. In this method, the old and new systems are run concurrently for same period. Its main attraction is that the old system is kept alive and it is operational unit. The new system has been proved for at least one system cycle. It allows the result of the new system to be compared with the old system before acceptance by the user, thereby promoting user acceptance. Advantages of parallel system. This method is very safe because if problem arises in using the new system, the organization can fall back to the new system without loss of time. Disadvantages of parallel system. Its main disadvantage is the extra cost. The difficulty is the impartability of user staff having to carry out the different clerical operations for 2 systems in the time available for one. Direct cutover. Direct cutover is the complete replacement of the old system by the new system. This method is introduced when there are insufficient similarities between the old and the new system. It is best to introduce a new system directly at a time when work is slack. This method is potentially less expensive but more risky. Thus, direct cutover is an effective method in so far so it minimizes the duplication of work but demand careful planning, testing and operational details of its complete success. Advantages of direct cutover. It is an efficient and fastest method, least expensive. Disadvantages of direct cutover. Require careful and advanced planning. It is very risky. It causes serious problems when the new system fails. Stop entire organization functions. Pilot approach. In this method, a working version of the system is implemented in one part of the organization, such as department knows that they are piloting a new system. Changes may be made to improve the system. When the system is considered beneficial, complete and fully functional, it can be implemented throughout the year by cutover method or by phase-in method. Advantages of pilot run approach. It has the advantages of providing providing ground for full implementation. Phase-in method. Phase-in method is used when it is not possible to install a system throughout an organization all at once. In this method, the new system is implemented in many phases. The conversion of files, training of personnel, or arrival of equipment may also force the staging of the implementation over a period of time. The representation of the phase-in method. There is no danger of total breakdown. This method reduces the risk inherent in a direct changeover of the whole system. Disadvantages of phase-in method. It cannot be used in situations where the time period provided for conversion is very less. It creates a problem in controlling the select parts of the old and the new system. Procedures. In this video, we are going to see about the procedures. There are many procedures and documents that are specifically used in the conversion phase. Conversion begins with the review of the project plan, the system test documentation, and the implementation plan. The people who are involved are the user, the project team, programmers, operators. The conversion part of the implementation plan is finalized and approved. Data in the existing files are converted into new file or database formats. Parallel operation of both the existing and the new system is started. Results of computer runs and operations for the new system are logged on a special form. Parallel processing is then discontinued. Implementation results are documented for reference. Conversion is completed. Plans for the post-implementation review are developed. After the review, the new system is declared operational formally. The procedures are backed by the activities that are unique to conversion. A point that should be given due consideration is that during the transition, the user should avoid making alterations or enhancements. The representation of the procedures for system implementation. Thus, the conversion process entails the following activities: converting forms and displays, training personnel, converting files or databases, converting physical facilities, converting administrative procedures. The representation of the system implementation tasks. Control measures. In this video, we are going to see about the control measures. The next step after evaluating the system security risks is to select the measures that are internal and external to the facility. These measures are generally categorized under the following heads: identification, access control, audit control, system integrity. Identification. A computer can identify persons using any of the following: password, fingerprints or voice prints, credit card, key or special terminal. Password. A password is the most commonly used means for checking the identity of people. Password should be hard to guess and easy to remember. Many users note down a difficult password or give passwords to associates, making their confidential data prone to potential unauthorized access. Fingerprints or voice prints. Although fingerprinting is commonly used in law enforcement, it is not suitable for the MIS environment. Voice prints, on the other hand, are emerging as a reliable method for verifying authorized users. This technique analyzes a person's voice against pre-recorded voice patterns of the same person. An exact match permits access to the system. Credit card, key, or special terminal. Credit card readers on terminals identify the operator to the system. The code along with the password gives added assurance of authenticity of the user. Access control. Access to a computer facility can be controlled by adhering to the following guidelines. Having a single entrance to the work area monitored around the clock. Installing intruder alarms. Installing a key lock, a cipher lock, or a badge-operated lock on the door of the work area. Posting a guard during working hours of the computer center. Issuing badges with new encoding, change locks periodically. Controlling use of files through a librarian. Segregating keys to operations area with a registration number logged in a control book when issued and marked "Do not duplicate." Encryption. Encryption is the process of making information unintelligible to the unauthorized reader and decryption, reversing encryption to make the information readable once again. Conventional cryptography uses a secret code or key to encrypt information. The same secret key is used by the receiver to decrypt the information. There are two basic types of cryptographic systems or crypto systems: symmetric crypto systems, asymmetric crypto systems. Symmetric crypto systems. DES and other symmetric crypto systems work on the concept of a single key being shared between two communicating entities. For every pair of partners engaging in secure communications, a new key has to be generated and securely maintained. Symmetric systems operate either in a block cipher or in a stream cipher mode. In the block cipher mode, data to be encrypted is broken up into fixed size blocks. Each of these fixed size blocks are encrypted and on decryption are again presented with data in blocks of the same size. The stream cipher mode can operate on data of any size and on encryption results in encrypted data of the same size as the plain text data. The DES crypto systems operate in the block cipher mode. Data is encrypted in 64-bit blocks using a 56-bit key. A final permutation generates the encrypted 64-bit data block. The strength of the encryption key is directly proportional to the key length. Asymmetric crypto systems. Asymmetric or public key crypto systems are built around the possession of a pair of keys, a public key and a private key, by each entity wishing to indulge in secure communication. As the name indicates, the public key is known to everyone, the private key is known only to the owner. The algorithm used to generate these keys is such that if either of the keys is used to encrypt a message, only the other corresponding key in the key pair will be able to decrypt it. Public key crypto systems are used to provide both the services of confidentiality and authentication or non-repudiation. Audit controls. Audit controls safeguard a system from external security violations and internal fraud and embezzlement. A problem with audit controls is that it is difficult to prove their importance until the system security has been violated. So, audit controls must be supported at all management levels and built into every system. The MIS department is one of the most error-prone areas in the chain. Programmers can reproduce, alter, and even sell software for their own advantage. In order to audit the maintenance process efficiently, there must be an audit trail from the modification request to the production programs. Many audit software are there to perform the jobs efficiently. Generalized audit software assists the auditor to check files and databases for consistency, accuracy, and completeness. Programs are also available to trace the flow of data through a program. Specialized audit software deal with the program specifics. For example, sales analysis programs reduce the volume of data in the database so that it can be managed with ease for the purpose of analysis. System integrity. System integrity is another line of defense that focuses on the working of hardware, database and software, physical security, and operating procedures. Program error is considered the costliest software loss. Such an error can be removed by using proper testing routines. Implementing parallel runs wherever possible is a good practice. Physical security provides safety against hardware destruction, databases and documentation, fire, flood, theft, sabotage, and eavesdropping, and loss of power through proper use of backup. Following measures can be taken to prevent destruction by fire. Sensors for early detection of heat, smoke, or fire should be installed. Safety of storage areas and facilities can be ensured by installation of efficient fire extinguishing systems. Direct communication channels to the fire station can be maintained. Fireproof chambers can be provided for crucial data, tapes, and other materials. Specific fire instructions can be posted at main places. Duplicate copies of important files, software, etc. can be stored off the premises. For preventing destruction by flood, the following guidelines can be adhered to. Computer facilities and storage should not have water pipes in the vicinity, that is, water pipes should be placed away from them. Ceiling and walls should be sealed against water seepage. Buildings should be constructed on levels above the ground to prevent rainwater from causing damage to the same. Efficient use of file library is another crucial security feature. This entails adequate file backup, trustworthy personnel to maintain the system. File backup implies maintaining duplicate copies of master and other important files and storing them at safe places. System acceptance criteria. In this video, we are going to see about the system acceptance criteria. Part of the system's development lifecycle, that is SDLC, is releasing a new or upgraded system from development to operations. Care should be taken during this transition to establish and ensure that all requirements for system implementation and acceptance are met. This standard establishes a requirement that system owners establish and document system acceptance criteria. Prior to releasing or transitioning a new or upgraded information system into production, system owners shall establish and document a system implementation plan. System implementation plan aligns test, delivery, and acceptance criteria with requirements. Minimum acceptance criteria shall include release or transition or conversion or implementation plans, security controls, testing and validation, functional, performance and user acceptance testing, data validation, contingency or backup plans, procedures for transferring software and hardware from development or test to production, CIO approval or other designated executive management to promote the system to production, design, training, administration, operational and security documentation. System evaluation and performance. In this video, we are going to see about the system evaluation and performance. After a system is put into operation, it is necessary to periodically review the system to measure the system performance against predefined requirements. For this, post-implementation reviews are held. Post-implementation reviews are conducted to determine how well a system performs against the performance specifications. It may give rise to the decision to undertake minor or major changes to the system, or even to start work on a system and/or terminate the use of the system. The first post-implementation review is usually conducted soon after the system has been implemented. This is also called the post-installation review. The subsequent review is conducted after the system has remained in operation for some time. Reviews are then repeated periodically. The decision to review may also be prompted when the project rises in prominence because of reasons like some major problem is encountered, someone puts forth a proposal for the new system, management finds that the system is not being used fully and benefits do not seem to be forthcoming. Typically, the review criteria are set up clearly and include review against performance specifications, review of training effectiveness, review of operating costs, review of benefits, review against user objectives. Inputs to the review include the various data which is to be analyzed like cost data operations, data on benefits or savings, problem logs, bug resolution records, customer complaints or requests, change requests, comments or correspondence. Testing. In this video, we are going to see about testing. Testing is a process to check the software or system whether it gives the required output or not on given set of data. In other terms, we can say that it is a process to fail particular system because in testing, we prepare all possible set of data and apply to the system to check it gives expected output. So system must give expected output or must be properly shut down in abnormal cases. Testing can be categorized into black box testing, white box testing. Black box testing. It emphasizes on input data and expected output of the system. It does not include the process from which the inputted data converts into required output such as internal control conditions, loop statements, etc. White box testing. In white box testing, we emphasize on each and every step from which data moves and converts into required output such as control statement, repetitions, constraints, comparisons, etc. Validation. In this video, we are going to see about validation. The process of evaluating system during the development process or at the end of the development process to determine whether it satisfies specified business requirements. Validation testing ensures that the product actually meets the client's needs. It can also be defined as to demonstrate that the product fulfills its intended use when deployed on appropriate environment. It answers to the question, are we building the right product? Validation testing can be best demonstrated using V-model. The software or product under test is evaluated during this type of testing. Activities involved in validation testing are as follows: unit testing, integration testing, system testing, user acceptance testing. User preparation. In this video, we are going to see about user preparation. Whether software is acquired from external vendors or developed in-house, several activities must take place before the system is fully operational. When a new system is implemented, it is necessary to ensure that all stakeholders and users are aware of the benefits of the new system. This includes company clients who will benefit in some way. It is necessary to manage expectations. In their anxiety to make people aware of the benefits of the system, some advocates oversell the system or promise benefits that may not be achieved in the early stages of operation. Whether a system is developed internally or acquired from an outside vendor, it requires education, training, and continuing support. If internal resources are insufficient to conduct training and education, an outside consultant may be required. Senior management must understand that sufficient time and resources are required for preparation. They should be seen to be promoting the system themselves to ensure the success of the implementation. Training. Training must be provided before the new system is implemented. Apart from training end users and technical specialists, it is important to train management to use the new system for decision making. If management is unaware of the key features of the new system and the information it can provide, the success of the new system will be limited even if users and technical staff are well versed in its operation. For training to be effective, it should be well organized and the objectives clearly identified for each training session. Training should be conducted in as a real setting as possible, using the final version of the system. Training tools include the documentation prepared earlier, that is system documentation, user documentation, and operations documentation. In the course of training, it is often found that documentation need to be modified. People considerations in systems design and implementation. Regardless of which conversion strategy is used, people considerations play an important role in designing and implementing a new system. In the real world, it has been shown that if users want a system, even a poorly designed system will be used and praised by all. However, if the users do not want the system and are forced to use it, even the best designed system will receive complaints and criticism. Site preparation. In this video, we are going to see about site preparation. Site preparation refers to the physical location of new equipment. A small system may require very little preparation. A large acquisition may include servers, telecommunication equipment, and other devices and could entail wiring, electronic circuits, security systems, and perhaps special rooms or facilities with restricted access and subfloors with cabling. If extensive networks are being installed and more workstations acquired, the whole building may have to be wired. Some organizations that have acquired major information systems have also built training rooms, project rooms, and technical support rooms. What is often forgotten when acquiring complete systems from external vendors is that space and facilities will be required for vendor personnel during implementation. Data preparation. In this video, we are going to see about data preparation. Data preparation or data conversion is the conversion of computer files. However, not all data need to be converted, and part of the data preparation step is determining what to convert. What an automated system is replaced by a new and different system, records and files will not be identical in the two systems. Often, a legacy system is purely file-based and contains redundant data. The IT staff must determine what to convert and how to do it. Often, conversion programs are written to convert existing data. Controls must be designed to ensure that all records are converted and that they are converted properly, and techniques for correcting errors and adding missing data must be designed. In the case of systems with large volumes of data, some organizations do not attempt to convert all data but keep historical data in a format that can be read by existing equipment for inquiry purposes only. Small business. In this video, we are going to see about small business. A small business will need preparation in many of the same areas as explained above, but these will generally be simpler. Training is still necessary so that users will understand how to use the various applications. Site preparation may simply be a matter of acquiring a computer desk with a printer stand and comfortable chair and ensuring that there is a good power supply handy with surge protection. User expectations must still be managed. Users should understand that an off-the-shelf package will not necessarily do everything on their wish list or perform in exactly the way they would like or used to. User Manual. In this video, we are going to see about User Manual. The User Manual is prepared reflexively because it is an item that must accompany every system. There are times when a user manual is discretionary. The important point is that the manual should be prepared only if it will serve the user. A manual is necessary when the user is geographically removed from the project team or when she or he cannot attend all the training sessions. If the user requests a manual, then one must be prepared. It should discuss, among the other things, the functions available to the user and what each can do, how they are executed, and how diagnostic messages should be handled. The manual should be well organized and indexed for quick reference. Graphics, pictures, and line drawings enhance the teaching value of the material. System maintenance activities. In this video, we are going to see about system maintenance activities. Systems maintenance or support is a process of fixing errors and adapting the system to the changing requirements. In a well-designed system, the systems analyst has considered ease of maintenance and, to a certain extent, designed the system to adapt to the changing needs of the business. The system maintenance process is comprised of 5 steps. Define and validate the problems. Benchmark the programs and applications. Understand the application and its programs. Edit and test the programs. Update documentation. Define and validate the problems. Before a system maintenance project is started, it is essential that the exact nature of the problem be clearly identified. Errors reported by users of the system can be caused by real bugs, user misuse of the system, or errors in the documentation. The most difficult bugs to identify are intermittent errors. Intermittent errors are hard to replicate and can be caused by software faults, hardware errors, or user errors. At this stage, it is important not to jump to conclusions and solve the wrong problem. Benchmark the programs and applications. Before making changes, the system should be tested to establish a benchmark. This is particularly important for measuring the performance of the system. A simple way to benchmark is to rerun the test cases, adding new cases where necessary. Without establishing a benchmark, it is difficult to determine the effect of the fixes. Establishing benchmarks is particularly important for online systems that may be sensitive to the timing of events. Understand the application and its programs. The process specifications and DFDs in the project repositories are the primary sources of information, as are the actual computer programs. If there is inadequate information in the project repositories, try to use any available software tools to aid in maintenance. A number of such tools are not restricted to the mainframe environment. For example, Access provides a tool called Documenter, which can be used to document all the objects in an Access database. The output from Documenter includes the properties, relationships, code, and user permission of all the objects. With this output, should be able to understand the logic and structure of a poorly designed access system. Edit and test the programs. After fully understand the corrective actions required, make changes to the appropriate programs. The most critical aspects of this activity is testing. Computer systems changing one aspect of a system often has totally unexpected repercussions on other parts of the system. You should rerun test cases after the changes are made and compare them to the established benchmarks to determine the impact of the changes, if any, on system performance. Update documentation. Documentation provides a record of the issues raised and what changes were made to the system. It provides an important source of information when planning future revisions or in the event that incompatibilities arise. System incompatibilities don't always appear in the most immediately revised version of the system. They may take several iterations to become evident, so having an audit trail of changes can be particularly useful. System maintenance issues. In this video, we are going to see about system maintenance issues. Reports suggest that the cost of maintenance is high. A study on estimating software maintenance found that the cost of maintenance is as high as 67% of the cost of the entire software process cycle. On an average, the cost of software maintenance is more than 50% of all SDLC phases. There are various factors which trigger maintenance cost goes high. Real-world factors affecting maintenance cost. The standard age of any software is considered up to 10 to 15 years. Older software, which was meant to work on slow machines with less memory and storage capacity, cannot keep them challenging against newly coming enhanced software on modern hardware. As technology advances, it becomes costly to maintain old software. Most maintenance engineers are newbie and use trial and error method to rectify problem. Often, changes made can easily hurt the original structure of the software, making it hard for any subsequent changes. Changes are often left undocumented, which may cause more conflicts in future. Software and factors affecting maintenance cost. Structure of software program, programming language, dependence on external environment, staff reliability and availability.